this lesson. This lesson we are going to see procedures and the very famous if statement. Okay, let's open it. Okay, procedures. What is a procedure? Procedure is basically a function. In fact, in many programming languages, it's called a function. The function takes some arguments in input, okay, uses them for executing some statements and returns a single value. So it's a sort of machine. You don't have to necessarily know what does it do inside. It takes some inputs, returns a value. But you have some wonderful examples of functions in mathematics. I'm pretty sure that all of you are familiar with the square root. The square root takes one number, one positive or zero number as input. Okay, so and returns a number. So takes which corresponds to its square root. I'm pretty sure that when you use the square root on your pocket calculator, or probably on your smartphone now, you don't have any idea what does it really do. Okay, you know that this is a black box. You put something inside and return something else. Okay, you can have more if you are familiar with Excel, which I really hope if you are at a master degree in economics. You should know that there are functions which takes more than one parameters, more than one arguments. The sum function in Excel takes an entire range and calculates the sum, but you have several others which takes more than one argument. Also in mathematics there are examples of functions which take more than one argument. The maximum between three numbers is the largest number. It takes three numbers and gives you back the largest number. Okay, so the procedure is basically a function. In computer science it works exactly as in mathematics. Takes some input and gives you back one. Pay attention because it gives you back only one output, and we say it returns an output. The Bacchus now form is this one. So it's a statement, a procedure. However, it's a statement in this case which uses more than one line. Okay, there's the def, it's a final word, so it's written exactly as this def. Okay, the name of the procedure, which as usual is any name starting with a letter and containing letters, numbers, or underscore. Okay. Then open a parenthesis, parameters, it's a list of expressions separated by commas. Well, in the def, it's a list of variables actually. Variables. Okay. Why have I decided to? Sorry, since I decided to have them capital, let's put them capital. Okay, let's leave tab non-capital. Okay, so parameters is a list of variables separated by commas. In this case, when you're going to use it, it will be a list of expressions. Then you have tab, followed by a block. Tab is the tab character. For those of you who are not familiar with it, you find it on your keyboard on the left of letter Q, okay, above the caps lock, more or less below number 1. It was used in old typewriting machine. Tab in old typewriters. That's it. Well, not so old actually, also the rather new typewriter machines. Let's see if I find a picture. This one. Okay, let me tell you the story. Why does it exist? It exists because typewriter machines were mechanical. So every time you press space, the typewriter machine had to mechanically move the paper on the left, and this creates a bump Okay, so if you have to put 6 spaces, which is typical whenever you write a long text, you to indent paragraph by 6 spaces, you have to press tab, tab, tab 6 times, and this will result in bump, 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 bump. And all, I can assure you, because I had used them, all your table was trembling, was shaken, bump, by these bumps. Instead, if you press tab, you just bump one time of 6 spaces, bump, and that's it. Okay. You could, in modern typewriter machines, you could set how much the tab will go on the left. Let's see, we have a slide. Oh, this is let's call it modern. Why do you always have the tab on the... Oh, this is an electronic typewriting machine. Wow, it still has the tab here. Okay. The tab in Python, it's used instead to emphasize a block. Okay. The block usually ends, but it's not mandatory, by the keyword return, it's a final word, followed by an expression. And this is what the procedure will return. If you don't write the return, the procedure doesn't do anything. So it doesn't return. So it's like, imagine you submit a number to the square root function, and the square root function doesn't give you the result. I'm pretty sure you will punch on your smartphone or on your pocket calculator to complain about it. A column statement, several. Okay, so the important thing is that this block contains statements, and all of them must be preceded by the tab. Also the return must be preceded by the tab. The tab identifies what is in the procedure and what is not. If you write an instruction which is not preceded by the tab, it means that it still belongs to the program, but not to the procedure itself. Okay? So, let's start immediately. Suppose you need to convert Celsius degrees to Fahrenheit. Don't worry, I give you the formula. Here's the formula. Okay, write a procedure to do it. So def, let's call it C to F, Celsius to Fahrenheit. Open parenthesis. I'm copying here. The parameter, there is only one parameter, is the Celsius degree. So let's small c, colon. Don't forget the colon. Now can you see, as soon as I press enter, automatically I have a tab here. 4 spaces. The tab in computer science is not 6 spaces anymore, it's usually 4 spaces. If you prefer, you can press the tab yourself. Okay. Don't put 2 tabs, because that's another meaning. So pay attention, because in Python is one of the few programming languages which doesn't use many parentheses, but use the tabs. Okay. So what do we do here? Well, we return... Well, let's do it. We calculate f as c by 9 divided by 5 plus 32. And then we return f. Done. Procedure is done. Sorry, yes. Let's test it, because if you press Shift Enter, the computer says fine. So now the procedure is inside the computer memory, but you have never used it. How to use it? Use it, for example, like this, C to F. How much? 60. No, 60 Celsius is a little too much. 30. Suppose you have to take a bath. 35. Sorry, print. It's always better to write print. 95. So 35 Celsius corresponds to 95. If you write 35 dot, it will give you 95 dot. Okay, that's it. 34. Okay. Can you see the problem of Python02? If I write 34, it's 93. If I write 34 dot, it's 93.2. People using Python03 won't have this problem. Okay, or better, if you write 9 point, now everything I write will give you me. Okay, fine. Okay, so pretty easy, as you can see. Declaration of the procedure. These things are called parameters. They're called parameters when you declare them, and they're called arguments when you use them. All the statements, you can put as many as you want, even no one. And then the last one is the return. Okay, remember, you must return exactly one thing. Okay. There is an alternative way to write it. Let me copy and paste it. result. Alternative. I can write it directly like this. So I'm not forced to write statements here. I can return immediately the result. This is typically done whenever your procedure is very, very easy. Whenever your procedure is very, very easy, you don't need anything in the middle. If your procedure starts to be complex, it's better to use some extra variables to make the calculation and then finally return the result. Because writing the return immediately can be done in many cases, writing the return immediately, but sometimes you have here a very long expression. Okay. To make things easier and more readable for people who have to read your procedures, it's better to do like this, or do the calculation and then. But it's just a matter of style. Okay, some remarks. First remark, f. Some remark, f. F is an internal variable. F and C are internal variables to the procedure. Okay. If you write here print f, what would you expect? And also print c. Would you expect 93.2 from here, 93.2 from here, and 34? No, because f and c are variables which do not belong to your program. They are internal variables to your procedure. And this means that at this point, which is outside the procedure, they don't have any value at all. Let's see. Can you see? 93.2, which is the result of this one. Print f and print c, name f not defined. Then the program stops, but also for c, name c not defined. Okay? So, remember that the variables that you use inside the procedure belong to the procedure. Okay, I will show you another, even worse thing. Look, c equals 0, f equals -3. Okay, print c. Look, if now I run this program, this c and f are variables belonging to the program, not to the procedure. The procedure starts here. Then I define the procedure. Okay. I use c and f, but this c and this f are different variables. Okay. They are different, they are not this c and this f. Okay. It means that when outside the program I ask print c and print f, you will see that you will read 0 and -3, not 34 and 93. Okay. 0 and -3. So this is because it's a typical mistake to believe that things inside the procedure are somehow exported to the program. No, the things inside the procedure remain inside, even though they can have the same name as things outside. It's never a good idea to have the same name as things outside because it will create confusion. But if it happens, the things, even if they have the same name, they are different variables. Okay? And the things inside the procedure disappear as soon as the procedure returns. When the procedure returns, variable f and variable c disappear. The computer erases them. Okay? This is the first. Second remark, the importance of the tab. Okay? I will teach you here now the importance of the tab. Suppose that, okay. So, first of all, do you have to use the tab? Well, I have a video. Let's see if I find it. So, a very educative video about tabs. You probably...
You okay?
Yeah, all good, great.
You know,
What?
my roommate's going out of town tomorrow, so if we want to come back here after Erlich's party.
Oh, okay, yeah, sure, that sounds good to me.
All right, it's a date.
See you then.
Richard, what's wrong?
Nothing. Nothing. Literally, it's all good. Come on.
Oh my God.
I'm sorry.
Your roommates are right. You really hate spaces.
No. I don't. It's not hate. Hate's a strong word. Truth be told, I do have a slight preference for tabs, but that's only because I'm anal and because I prefer precision.
Well, not to pick a fight here, but if you really care about precision, wouldn't you use spaces? But whatever. Once it goes through the compiler, it's the same thing, right?
Yeah, technically, yes. I guess I just don't understand why anyone would use spaces over tabs. Like, if it's all the same, well, why not just use tabs?
Because it could look different on other people's computers.
Tabs create smaller file sizes, all right? I run a compression company. Trust me, I've devoted my life to minimalizing file sizes. It's what I do. I mean, I do not get why anyone would use spaces over tabs. I mean, why not just use Vim over Emacs?
I do use Vim over Emacs.
Oh, God help us. Okay, you know what? I don't think this is gonna work. I'm so sorry. I mean, like, what? We're gonna bring kids into this world with that over the heads? That's not really fair to them, don't you think?
Kids? We haven't even slept together.
And guess what? It's never gonna happen now because there is no way I'm gonna be with someone who uses spaces over tabs.
Richard!
Wow, okay. Goodbye. 1 tab saves you 8 spaces.
Oh my God. Richard, what happened?
I just tried to go down the stairs 8 steps at a time. I'm okay, though.
See you around, Richard.
Just making a point.
Okay, stop. Okay, she is right. Once it goes to the compiler, or in the case of Python, the interpreter, spaces and tabs are exactly equivalent. So you can use 1, 2, 3, 4, or better. 1, 2, 3, 4 spaces. Okay, in this case 4, not 8. Or a tab. It's much more convenient to use a tab, however. Even though I think not even the interpreter, even Anaconda will convert. If you check, can you see now you have 4 spaces? You convert your tab into 4 spaces. So they are pretty equivalent. Even though tab it's much more convenient probably to use. Okay, so now I hope that I convince you to use tab or whatever here. Okay. Otherwise, if you just do something like this, okay. The interpreter will believe that this thing here belongs not to the procedure, and also this thing here, and we'll get really puzzled of what you're trying to do. Okay. Let's see another example. Def, let's call it first. It accepts A. Okay, this doesn't return anything. Okay, so it's a function procedure which doesn't return anything, but it prints something. Let's see, A equal A plus 1. So it prints A incremented by 1. Okay, let's try to do it. First 7. It should print 8. Okay, let's print. Okay, this prints automatically 8. I don't have to print. Okay, doesn't do anything. Doesn't return anything. It prints A. But let's see, prints A and prints double A. Oops. Sorry, 2 by A. Okay, so it's a procedure which doesn't return anything, doesn't give you anything back, but prints something. Okay. Look at this procedure. If you do like this, it prints. Look what happens if I put this instruction here. Okay. A is not defined because the instruction here is trying to print A, but outside the procedure. And outside the procedure, A has no definition at all. Okay? So the function here does the program here does the following, memorizes the function, tries to print A outside the procedure, wrong. Okay? Here inside the procedure, outside the procedure. Inside, outside. Let's do. Okay, here it will be more convincing. Now what will it do if you do like this? It will store 99 to A, then it will define this procedure, then call the procedure with A equal to 7, so it will print 7 and 8 and 16. 8 and 16. Okay. If you do like this instead, it will store 99 into A, define the procedure, print 99 by 2, which makes 198, I think, and then print the procedure with 7, which means 8. Okay. You see? First it prints this one, then it calls the procedure. And like this it will set 99 in A. Define the procedure, but this procedure doesn't do absolutely anything. Takes an argument, increments it by 1, doesn't return anything, doesn't print anything, then print this A here, and then call the procedure which doesn't do anything. So pay attention to where you put them. I have seen in the past students putting them really randomly. Pay attention, because it's a severe mistake to write something like this if you mean something like this instead. The situation can be very different. Okay, let's see some important remark on often forgotten things about procedures. First of all, just a remark of naming. The things between parentheses are called parameters during the procedure definition and argument when you use it. So here A is a parameter, 7 is an argument. C is a parameter, 34 is an argument. Okay. Even if you call it A again, because I'm using this A here, in this case A is a parameter, this is an argument. So parameters in the function definition, arguments when you use it. Do not forget the column. I will forget it, so please remind it to me. I will always forget this column here. All statement must be preceded by a tab or 4 spaces. If you do not put it, it will belong to the ordinary program and not to the procedure. There is almost no reason for writing something after the return, so return should be the last one. If you return something, like here, if I write return and then I write, for example, print hello, I'm sorry, when the function returns, when the procedure returns, it's over. Look. Can you see? You don't see hello. Okay, because it has already returned. There are very, very rare usages, but I don't, probably no one after the final return. There can be cases in which the return is inside an if, but usually if the return is a plain return like this, there is no reason to write something after. And please use the return. If you don't use it, it means that your function is not returning anything. In that case, it may be a function which prints something, but if you don't return and you don't print, I'm wondering what is your function doing. Variables used inside the procedure have nothing to do with variables outside. For example, the variable f used inside the function is not the variable f outside. Let's call it, I use the small f. Let me make it capital so you see it better. These are for you, Oh. What if I write B? Oh. The variable f. This is a trick to make it emphatic. Okay. We have already done. Try to print the variable f inside and outside. This means that if a function does not return, it does nothing except print if it contains some to print. It is not mandatory to store the value that you are going to return in a variable. You can directly return everything in one line. However, for long procedures, this can make your life easier. The procedure defined by def doesn't run by itself. It must be explicitly used by a program. This is a mistake many students do. So if you just write a procedure, look like this, Very well, very nice procedure, but don't expect it to do anything, because now the procedure is inside the computer memory, but you're not using it. So you must use the procedure. Okay. So if you don't use it, it's a nice procedure, but when using a procedure, you pass as arguments expression, and thus you may paste values directly, variables, or even complex calculations. So here you can pass a variable, you can pass a number, or you can pass a complex calculation. Okay. Sorry. Okay. Okay. So inside as arguments, the procedure accepts expressions when you use it. Let's write also when you use it. Usage. Name. It's a statement. It's not a statement, it's an expression, sorry. Composed of name, open parenthesis, arguments. Okay, that's it. Where arguments are generically expression. A list of expression. List of several expression separated by commas. Okay. Okay. Don't worry, let's do some others. Define a procedures that accept as parameters a string and a number, and returns the string starting from the index defined by the number. So let's do it together. Save. Def b second sn. Okay. Well, concerning names, it would be nice to write meaningful names. Now we are doing only examples, but in a real program you will write meaningful names, otherwise nobody will understand. Colon. Result equal the string starting from the index, so n, and going up to the end. Return result. Okay. Well, again, it's not necessary. I can return directly this one, but I prefer to write like this, which is clearer. Let's test it. So, done. Second. Hello. Two. Low. Okay. Fine. Okay, I think there is nothing else to tell you. Two parameters, here are the two arguments. Sorry, it's better to print. Use it at many times, I already told you, but many times I forgot to write print. It's not a good idea, because if you forget to write print and write just expression, it will print the expression. But if you have two expressions, for example, it will print only the last one. So it's always better to write always print. So low, okay. Okay, and what if I write 99? Probably will give me an error. No, will not print anything. Because S of 99 it's empty. Okay. Okay. Op. Let's do some exercises. These exercises are not meant to be done because a programming language you learn it just by watching at this video while you're sleeping. If you're sleeping, wake up. These exercises are meant to be done. So are meant to be done alone, not watching the video as I do it. You're meant to stop the video and do them. Okay, stop the video. Okay. What does this procedure do? Tac. Let's add space to answer. Let's put spaces markdown. Okay. Now stop the video and think. Okay, let's see. This procedure increments the argument by 1 and returns it. I think there is nothing else to say. I am puzzled of what happens if you pass as argument a string. Probably an error. Let's see. So I run it. Inc of GG errors. Yes. Let's erase the solution so I don't give it to you by mistake. Okay, which 4 values will this code print at the end of its execution? Stop the video. Stopped. Okay, let's see. N equal to 5, it increments and returns, so it will print, according to my opinion, 6, then n, which is 5. Pay attention, because even though it increments n here, okay, it does not increment this n, because this n and this n are 2 different n's. Okay. Then increment n plus 8. So you pass 5 plus 8, which makes 13, incremented 14, so 14. And the last one, again print n, 5. I don't see any reason, it's a trick. This is just to emphasize the fact that this n will never change if you just run the procedure. It doesn't change by this one, doesn't change by this one, doesn't change by this one. Because this n is not this n, and not this one. The n inside the procedure is a different n. In computer science, these are called scopes. So the scope of the procedure is this one, and the variables inside here have their own scope and die. Okay. As soon as the procedure is over. Okay. Now, what does this procedure and what does this piece of code do? Stop the video, try to answer alone. Okay, let's see, the procedure, well, takes 2 numbers, no, not 2 numbers actually, takes 2 things and sums them, because they can also be 2 strings, it's allowed to sum strings that are concatenated. And the piece of code will write 10. Ooh, difficult. Why do I give such easy exercises? What does this piece of code print? It prints 10, and then it prints nothing. It gives you an error because A is not defined. A exists only inside the procedure, but we are outside here. It's not defined. It gives you an error. Let's see. No, it doesn't give. It doesn't give an error because A was defined above by another time. So I didn't clear my variables. Okay, you should do restart and clear output to clear everything. Now if I run, I get an error, yes. Restart and clear output. Okay. What does this piece of code print? Some, see, algorithmic thinking prints. It's a concatenation of 2 strings. Okay, easy examples. Again, I have a lot of exercises on procedure because they are one of the core aspects of any programming language. Define a procedure called, every time, I repeat for the 1000th time, every time you must stop the video, otherwise I will scare you shouting. You must stop the video and do the exercise. Define a procedure called square. Okay, now stop. After I read it, stop the video. Which accepts as parameter a number and returns its square. Difficult. Use it to calculate the square of a number. Then use it twice to calculate the 4th power of a number. Okay, stop the video. Do it. Okay, done. Def square and look. I am particularly lazy. I don't write. Okay, done. I think that in Python you can write a square also in this way. Okay. let's see, square of 3, 9, sorry, print. And now print square of the square of 3. You know what is the fourth power of 3? So 3 by 3 makes 9, by 3 makes 27, and by 3 is beyond my mathematical capabilities. It is 27, 7, 14, 28, 36, 12, 148 should be. Let's see. No, 81. My mathematical capabilities are gone. Ah, yes, because this is 9 and 9, 9. How? 3. 9, 27. 27 by 3, not by 4. Then. Okay, 81. Okay. My mathematical remembrance is far beyond in the past. Far away in the past. Okay, so this is just to teach you that you can, since the result of a function of a procedure is an expression, after all, but it's an expression. It's a number or a string. It's a variable. It's a number of a string. You can pass it as argument to another expression. So it's not forbidden to combine expression in this way. You can because here inside you can put anything which at the end gives you a number. Okay. Okay. Define a procedure called a base, which takes as parameters two strings and returns a string composed of the first one, followed by two repetitions of the second one, followed by the first 3 characters of the first one. Stop the video. Def a base. S1, S2. This is the worst choice you can make of parameters. Result equal S1. Alt 5. The first 3 characters. So colon 3 means character 0, 1 and 2. Okay, fine. Let's try it. Always test your functions. And maybe if I return something, it will give me something. Okay, Paolo Coletti, Pao. Okay, yeah. Wow. Oh, now we are over with the procedures. Means we are over with talking about speech-tree procedures, but we'll use them from now on forever. Let's talk about making decisions. Before starting to make decisions, you have to introduce the comparison operators and the logical expression. What is a logical expression? Well, you have seen thousands of times, even in your life, if not only mathematics. A logical expression is this one smaller than that one? Is this one equal to that one? So, a logical expression. In fact, if I print it, this is a logical expression. Can you see? Because it's expression, comparison operator, expression. I remind you that a variable is an expression. Okay? This makes a logical expression, which is an expression, by the way. Okay? And that's why I can print it. This is a comparison operator. You have here the list. True. The logical expression can be only true or false. 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 True. Okay. Easy peasy, no? Let's see what happens if I choose this one. True. So also this one is allowed. Let me write it. This one and this one are the same. They both mean inequality. In fact, this one should be false. Okay. Okay, so logical expression, easy peasy. I mean, I don't have to talk too much about them. smaller equal. The only important remark is that the equal is this one and never this one. Because this thing here in computer science means assignment. So means take what is have on the right and put it on the left. It does not mean equal. I know there are some programming language, some old programming language for which this one means equality. But it's not the case of Python, which is not an old programming language. This one is the equality. Okay? Because this one has another meaning. You have to repeat it another time. Okay? It's a typical mistake. A typical mistake of doing something like this. Now I think it will give me an error. Yes, but if I choose do something like this, I'm not sure that this will give me an error. Yes, it gives me. Other programming languages don't give an error for this one. Simply assign 5 to A and prints the value of A, for example. Python is kind, it gives you an error. Oh, kind Python. Okay. You can use comparison also between between variables and between complex expression. Okay. True. 4 by 2, 8 minus 3, 5. Okay, so you can just put also on this side, obviously. You can put also parentheses. Where is it? Okay, I don't explicitly specify it, but obviously it's not forbidden to put parentheses. False. Okay. So, true and false, as you have already guessed, okay, are two expressions by themselves. So you can choose, look, I know it's pretty bizarre, but print true, true. Print false, false. I think that you can also make some arithmetic. False plus true makes true, eh? Yeah, 1. Okay, it's 2. Let's see. Makes 2. Ah, okay. Because whenever you use the plus, false is converted to 0 and true is converted to 1. Okay. For example, this one, false by true makes 0. Plus true makes 1. 0. Okay. So you can also make some arithmetics. There are expressions, but there are values more than an expression. So there are, in any case, you can also do some arithmetics with them. Okay. And there are also variables. So I can define A equal, in this case, A will be true. So in A, I've stored the value of this. A is a Boolean variable. Okay. So we have now 4 types of variables: the integer, the float, contain integer number, contain number with decimal digits. They are interchangeable. I mean, you can add an integer to a float without any problem. The result will be always a float. String, they are not interchangeable with this one. If you add a string to a number, error. And Boolean. Boolean are only variables which are true and false. They are interchangeable with the numbers, because if you A plus 1, I think the result will be 2. Yes. Because if you make a mathematical expression using a Boolean and numbers, the Boolean is automatically converted to true 1, false 0. Okay, so you have integer, float, Boolean, which are sort of mathematics, and then strings. Okay, there are tons of others. Don't worry, we will see many of them. Okay, and now why do I break your beep with these things? Because they're useful for the if. The if is the king of computers. Okay, and it's used for controlling and taking decisions. The syntax is similar to procedure: if followed by an expression, it's the expression that you check, followed by a colon, then a tab and a block. this block is executed only if the expression, logical expression, not expression, logical. Is the logical expression I've defined it? Yes. The if is executed only if the logical expression is true. If it is false, it's not executed. I have to make examples. A equal 5, B equals 6, if A smaller than B, colon, print, hello. Okay, now let's run it. Hello. But if I choose as A9, doesn't print anything. Okay. Please, also here, look at the importance of indentation. Sorry if I do it now, but I would like to make it. Okay. Cuckoo, I'm back. Look at the indentation. Here I am. Okay. Now in this case, nothing is printed. In this case, both are printed. Okay. Let's go back to the case where nothing is printed. Nothing is printed because A is 8 and B is 6. So nothing is printed. Okay, right? Okay, but what happens if you do like this? If you do like this, it means that print, it's not part of the block anymore. It's part of the standard program. Therefore, this one is skipped because the expression is false. But this one is not skipped because it's part of the standard program. So, here I am. Okay, so especially in the if, writing like this or writing like this makes a big difference. Like this, it's part of the block, of the if block. Like this is not part of the if block anymore. Okay. Like this is a mess because it has some other meaning. So don't put random indentations just because you aesthetically like it. Okay. Okay, so pretty easy. Also here you can write some extra thing. Inside here you can change the value of the variable if you like. If A is too small, let's double it. This is a dirty trick to be able to concatenate a number, A is a number, with a text. So because if I write plus A, it will not be allowed because A is a text and A is a number and here I am is a text. You just convert it to string before. Okay. Now if I choose as A4, it works. If I choose as A99, doesn't print anything. Okay. Okay. I think that with a basic if I have told you anything. Let's go to some one exercise. Oop. What the fuck? Oh, why do I have here? I don't want anything here. Mystery of... Okay. Define a procedure bigger that takes as parameters two numbers and returns the greater of the two. For example, bigger than 7 returns 7, bigger than 1 returns 3. Okay. Stop the video, try to do it alone. Whenever you see exercises, it means that you must try to do it alone. Def bigger AB. If A larger than B, print A. No, not print, return. Okay. Now, look, I write here return B. Okay, let's see why. Look, if A is larger than B, the procedure returns A And that's it. The procedure ends. I told you the procedure ends whenever you return something. Okay. If the procedure does not end because A is not larger than B and so this block is not executed, it goes on. Well, if you go on, it means that A is not larger than B. In this case, it returns B. Okay. Pay attention, because it's doing like this, it's totally meaningless, because it means that both are inside the block. Once you return A, well, you will never return B. Doing like this is much different. It means that return B is not inside the if block. Still inside the procedure, but not inside the if block. So now you understand the meaning of two tabs. Sometimes you have a block inside another block. So this is the procedure block, and this is the if block. So pay attention, because in this case, returning the A here means that if A is larger than B, you exit the procedure and returns A. If it is not, you do not execute this block, so you go on. If you are unsure, hey, I'm going on. Okay. Okay, so if you are unsure of what your program do, you can write some printing in the middle, which your program will tell you where it is. So, for example, hey, I am. Okay, so let's try to do it. Bigger 1-3. Hey, print. Hey, I'm going on. It means that 1 is not smaller than 3, so it skipped the if block, so never printed I am inside the if block. Just print, hey, I'm going on, and returns the B. Okay, let's see. 7-3. Hey, I'm inside the if block, so it tells you that it's inside. You may laugh, but it's a technique which I still use after, let's see, 36 years of programming. Sometimes I'm not sure whether my program really does what I do, so I'm asking him to tell me where it is. Tells me, yeah, I'm inside the if block. Usually I put bad words here. Usually, fuck, why am I here? Okay. Okay. At this point, you probably feel the necessity for the else. Because sometimes if this is true, okay. Otherwise, I would like to do something else. Okay. So, yes, there is the else, don't worry. Here. If expression, called a logical expression. Tab block, else does not preceded by a tab, and then tab block again. This is the true block, and this is the false block. Okay. Rewrite bigger procedure using now else. So def bigger a comma b. Now you will see that with else it's much more readable. It's the same, but it's much more readable. If a larger than b, colon, return a. Else, return b. Can you see? It's the same, The same, but much more readable now. Now you clearly understand what does it do. If a is larger than b, you return a. Otherwise, if they are equal or if b is larger, you return b. Do I have to test it? No, I don't want to offend your intelligence testing. It's exactly the same. Okay. Rewrite a bigger procedure, putting the result in a variable before returning it. Since I am lazy, but you should not be, result equal a. Okay. This is even more readable, I think. Okay. If a is larger than b, I put a into result. If otherwise, I put b into result. And at the end, I return result. Pay attention that the return result, it's not indented. If it were indented, what would the result be? What would the effect be? The effect would be that if a is larger than b, I will never return anything. Okay, if you indent like this, then you should put it like this. Okay. much better not indenting it at all and do it at the very end of your procedure. Okay? A perfectly equivalent thing is this one. This is perfectly equivalent. Look, result equal B. Perfectly equivalent. Think at it. I will not explain it, but think at it. Just stop the video and think. I will not tell you any comment. And think why it's perfectly equivalent and works. So this one, this one, this one, and this one are all equivalent. They all work. Okay. Define procedure isFriend, which takes as parameter a string and returns a boolean indicating that string is the name of a friend. Okay, but how do I know whether somebody is my friend? We assume that you are a friend with all the people whose name starts with capital P, obviously, and no one else. Okay, his friend Paolo returns true and his friend Michael returns false. Fine. I like this procedure. Def is friend. Name. If. How can I say name starts with P? Well, name of 0. It's the first letter of name. Equal P colon. Yes, you can use equal also for letters. I don't think it will work if you use smaller. I don't think it will check the alphabetical order. You never know, but I don't think it will do. In this case, return true, else return false. As usual, you can write this print. You can write this function in 20 different ways, as explained above. This is one of them. Okay. Now, sometimes this is not enough. You want to check whether this one is true or that one is true, whether this one is true and that one is true. So sometimes one check only is not enough. Even though you can put if, it's more convenient to use and or not. And or not are logical operators, so they are put between logical expression and returns a logical expression. They are used like this: logical expression and logical expression or logical expression, not logical expression. Well, I don't want to offend your intelligence explaining you what does not do. Well, better, I will offend just because I want to be sure. Not reverses the logical expression. If this is true, becomes false. If this is false, becomes true. Not everybody can grasp it. And for this logical expression to be true, both must be true. Okay? Pay attention, because common language, it's misleading in this case. Okay? So, for example, I told you, oh, I have a car and a bicycle. It means that I have both. So both are true. Car, have bicycle are both true. If I just have the bicycle and say I have a car and a bicycle, I'm lying. Okay? If I ask you, do you have a car and a bicycle? And you answer yes, I assume that you have both. Okay? Pay attention, because or it's somehow misleading, especially it's more also, and there are some examples which are misleading, but I don't want to mention them to avoid creating confusion. Or instead, in common language, it's very misleading. If I ask you, do you want an ice cream or a piece of cake? Okay, I'm not telling you that you can get both. I'm telling you that you either take the ice cream or you take the piece of cake. If you answer both, it will be very unpolite. So this is not the meaning of or in computer science, and it's not the meaning of or in mathematics also. Okay. In mathematics and computer science, the meaning of or it's more similar to this one. You can apply for this job if you have a degree in economics or a degree in law. Clearly, if somebody has a degree in economics, can apply. If somebody has a degree in law, can apply. If somebody has a degree in economics and a degree in law, can apply as well. We wouldn't reject this application, obviously. Okay. This is the meaning of or in computer science and also in mathematics. It means that just one of the two can be true and the entire expression is true. Okay? If both are true, even better, the entire expression is true. Okay, so the meaning of or is just one of the... The meaning of or is the one with the degree, not with the one with the ice cream, remember. Modify is friend to return true also for people whose name starts with A. Use 3 different methods. Wow. Let's see. Okay, so modify means that I can be lazy. Okay, if name equal or obviously name 0. Okay, let's try. Yeah, true. Okay. Let's see some other possibilities. Another possibility could be the following. If name is equal return true, if name 0 equal A return true. I remove the else at all, return false. Okay. If it starts with P, return true and the function is over. If it starts with A, returns true and the function is over. If the function is not yet over, it will return false. Another possibility. Let's see if I can remember a third possibility. Let me see. Let me think. I can do like this. If the name starts with P, return true. No. Else. Okay, this is the most terrible one to read. Whenever I have to read other people code and I see something like this, I put... okay, but it works. If the name starts with P, I return true. Otherwise, I check whether... Can you see? All these things is inside the else block. So this is done, all this is done if the name doesn't start with P. Otherwise, I check whether the name starts with A. In this case, I return true. If it doesn't, well, if it doesn't, means that it doesn't start with A, and we are in the block in which it does not start with P. In this case, I return false. Okay. So these are 3 equivalent ways of writing it. I think that this one is the most comprehensible. The second most comprehensible is this one. This one is the most contorted. But logically, the logical reasoning is the same. Whenever you see things like this, please take your time to make your logical reasoning. Okay, save. Another difficult exercise. I have to write it in yellow. So B font color equal orange. You will end this video course also learning how to write HTML. Oh, oops. I didn't close the B. Difficult. Okay. I've also learned that BR means break, so go to a new line. Okay, define a procedure biggest that takes as parameters 3 numbers and returns the biggest of the 3. Stop the video, try to do it alone, dedicate at least 5-10 minutes, because this is not the kind of subject which you learn just by hearing this video while you're cooking. Okay? You learn it only by writing with your fingers. or with your voice recording device, if you are able to write code with a voice recording device. Okay, stop. Okay, now let's do it. Did you stop it before? A, B, C. Oh, be prepared because this is hard. Okay. How do I return the biggest of the three? Well, I have to check whether A is larger than B and larger than C, or whether B is larger than A and larger than C, or whether C is larger than A and larger than B. Let's start doing it in a very inefficient way. This is inefficient. If A is larger than B, if A is larger than C, in this case, return A. Stop. Stop means I go back at the beginning of the program. So in this case, A is the candidate. If B is larger than A, if B is larger than C, if C is larger than A, larger than B. Okay, this is the most inefficient way of writing it, even though it's the one that people logically do. It also doesn't work in case two of them are equal. If, for example, you submit 773, it will not work. So let's make larger or equal, because larger or equal it's fine anyway. This works even if two of them are the same. This is the most inefficient way. Let's test it. Print biggest 7,7,9. Result is 9, 7,7,3. Result is 7. Okay. Okay, let's make it more efficient. How to make it more efficient? Well, if A is larger than equal to B, then I check whether A is larger or equal to C. At this point, let's see. In this case, A is larger or equal to B. Okay. Let me think. Okay, else. At this point, I'm sure that A it's not larger or equal to B. Okay, so it's pointless to check this thing here because B for sure is larger than A. Okay, this makes the procedure a little more efficient. I check whether A is larger or equal to B. If it is, I check whether A is larger or equal to C. In this case, I return A. Otherwise, here I'm sure that A it's not larger or equal to B, so it's smaller, so it's B the larger one. I check whether B is also larger than C, and I return C. Okay. Well, if I'm here, it means that C is larger than A or larger than B. So if I'm here, it's automatically C the largest one. Because this covers all the possibilities that A is the larger. This covers all the possibilities that B is the largest. If I'm here, if I arrive here, there is only one reason. It's because C is the larger. Okay. So much more efficient. Much more efficient but difficult to understand, I would say. It's much easier to understand if you use the function procedure bigger. That's it. Do you remember the procedure bigger? Let's rewrite it just def bigger A, B. Okay. Now, using the procedure bigger, I rewrite biggest, def biggest, if A is larger than B, larger or equal to B, I return simply the bigger between A and C. If A is larger than B, B is out of our consideration, because in this case I return the bigger, else I return the bigger between B and C. Okay, done. Don't need to return C. Let's test it. Biggest 7, 5, 9. In this case C is the larger one. Oh, print. Type error. Where is it? Print biggest. Biggest. Big. What the there's some mistake somewhere. Bigger. Biggest. Biggest takes exactly 2 arguments. Ah, yes, sorry. Okay. 9. Nine, 7. Okay. This one very difficult. Must be. Very difficult. Write biggest using a single line in the block. A single line, so I'll return directly. Okay, let's see. I obviously must use bigger. Maybe. Using I'll be writing here, using okay. How can I use a single line? Let me think. Here I check whether A is larger than B. Maybe I can return the bigger than the bigger between A and C, and the bigger between B and C. Let's see whether it is. I admit this one didn't even came to my mind. I just picked it. Let's see whether it works. This one will take the bigger between A and C. This one will take the bigger between B and C. So A and C. So if A is the bigger, it will come up here and will for sure be bigger than this one. If B is the bigger, it will come up here and will for sure be bigger than this one. If C is the bigger, it will come up here and here. So the result will be C anyway. Let's see. Let's do the test. Fine. Okay. At this point, in theory, the video is over, but when I was preparing this lesson, I forgot an important thing, which will be done live now. So you see also how do I prepare the lesson. Okay, markdown. Else if. Okay, let's see. Python else if. Elif, yes, because every programming language else if. Okay. Sometimes you feel the necessity to use the else if. Okay. So for example, look here. Where is it? Here. Else if. Sometimes you feel the necessity to put these two things together. For example, typically when you have to check a list, for example, if this one is Paolo, else if it is Anna, else if it is Francesca, else if it is Julian, else if it is Michael. So you need to make a complete list of checking. You can write it in another way. You can write if it is Paolo, else indent if it is Anna, else indent, but you will start indenting, and you will start writing the code here at the end of the screen. So there is the command to join together else with else if. So we expand, or is it this one? Control C, Control V. Okay, so elif logical expression. Okay, and optional you can have an else at end, obviously. Okay, but let's not put it. Okay, so elif logical expression. You will execute this block only if this if was wrong and this if was true. Example immediately. So for example, s equal Giovanni. If s equal Paolo, sorry, colon, this point elif it's just a stupid example, print else. It's not mandatory to have the final else. Let's see. I run it. It is somebody else. Okay, so I didn't put any procedure. You can use the if obviously also outside procedure. Until now we have always. So tail if is equivalent to else colon indent. Okay. The problem is that if you write it using the else's, let me first keep it with elif. Okay. I will write equivalent here using the else's. Else colon if indent. Okay, then here else colon if indented, then else. You can see I'm starting to go far away to the right. If the list is long, I will start writing things here. This is perfect equivalent. It's perfect equivalent. So the else if can be abbreviated with elif, so you don't have to indent. Oops, this one's a mistake here. Okay, save. Okay, let's see quickly the exercises that I prepared for you. These exercises are meant to be done at home, so I just comment them. Define a procedure says that takes as parameter a string and returns your name, followed by a colon and a space, and the input string enclosed by double quotations. For example, says hello returns Paolo colon space hello between double quotation. Test the procedure with 3 different input strings. So one a standard one, another one with an apostrophe, another one with double quotation, so just a bit tricky. Consider the procedure mystery here below, which uses the procedure test, which returns a boolean, and for which you do not have any clue of what does it do. Okay. You have test defined some by other people. It's so complex that you don't have any idea of what does it do. Which of the following procedures does exactly the same as the procedure mystery? For each one, write a comment convincing me of your answer. Oh. M1. Sorry, this. I don't want to. It's possible that every time. Okay. Oh, difficult. That's very difficult as usual. B font color equal orange. Difficult. Close the font and close the B. I didn't close the B properly. Define a procedure median which takes as parameters 3 numbers and returns the median. For those of you who don't know what the median is, apart from suggesting a course in statistics, an urgent course in statistics, the number in the middle according to numerical order. You may use other procedures to build in class, but in this case write them here. Okay? So median of 1, 2, 3 is 2, median of 9, 3, 6 is 6, median of 7, 8, 7 is 7, 7, 8, so the number in the middle is 7. Test the procedure with these 3 examples. With the 3 examples above, because otherwise you expect me. Okay, and just to remind you that you have to test the procedure. Okay, but only 2 exercises, or only 3 okay, that's it. Goodbye.